Okay, welcome to this video. 1.10, highest common factor and lowest common multiple. So with learning goal, we're going to be able to still be able to solve problems involving comparison, addition and subtraction of integers. And your success criteria for this one is to be able to find the highest common factor for a set of numbers and find the lowest common multiple for a set of numbers. Okay? Alright, so factors and multiples are things that link numbers together, okay? And so it's important to be able to realize that the numbers 24 and 36 have a lot of things in common. One of them is that they both share factors of 6, of 2, of 12, of 4, and 1, obviously, and and 3. I think that might be it off the top of my head. Sounds good. And those numbers here are common factors for both of these two numbers. And so they're in a set of factors for both of them, and they link them together, and it's important to realize that numbers can be related in those ways. Okay? Now, a couple of key ideas. There's two big ones for this one. The first is looking at this idea of being able to find the lowest common multiple, or, as you may have seen before, LCM for a set of numbers is the smallest multiple that is common to each of the numbers. Okay? Now, in the past, and now I want you to do it this way still, I think, let's see how we go about chucking a table in there. That sort of seems to work. Okay, so here's going to be our table values, and let's just say we want to find the lowest common multiple of, let's embiggen it, see if I can, maybe not. Okay, so let's say we find the LCM of, let's just say 6 and 9 for the sake of it. Okay, so what I want you to do is draw up a little table. So we're going to have our two numbers, so 6 and 9, and remember our multiples of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, right, so 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. Now you can fill that all out if you want to, but you'll start to recognize some numbers that are kind of familiar with the other number you're about to test. And so, for instance, let's have a look at 9 now. So 9 times 2 is 18. Now, usually you could fill all this out if you want to, but when we're doing lowest common multiple, because remember, it is the lowest number multiple that is common to both of them, okay, we straight away, I've listed 3 times 6 is 18, but 9 times 2 is also 18. Okay, so we write LCM of 6 and 9 is equal to 18. Okay, so super easy way of doing it. I really recommend and kind of want you to really draw this little table up. Just has to be really quick. Don't use rules and stuff. Just kind of quickly scratch it out. Just so I can't really make it even look kind of neat with the tablet I've got here. Okay, so really want you to be setting out your lowest common multiple work like that. Okay, highest common factor. I'm going to give you a bit of a choice. Okay, so highest common factor, or HCF, for a set of numbers is the largest factor that is common to each of the numbers. Okay, so let's just say find HCF of let's just go 36 and 24. Yeah, it's pretty classic two numbers to find. A lot of set of factors and things. Okay, so what I want you to do now is I want you to set it out by drawing yourself like a nice little T table like this. We're going to put 36 on this side, 24 on this side. Okay, now, it's a good idea to go from 1 downwards. Okay, so 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't have 1, 6 times 6, okay, and we're finished. Okay, so there's no 7s, 8s, when we get back to 9, we're back to 9 times 4 again, etc. Okay, so that's our factors for 36. Now let's do our factors for 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, then 5 doesn't work, 6, we're back to 6 times 4, etc. Okay, so we've listed out the complete set of factors for each number. Now we can sort of like circle, or at least underline maybe, every single common factor. So they both have 1s, they both have 2s, they both have 3s, they both have 4, they both have 6, they both have, they don't both have 8, they don't both have 9, but they both have 12. Okay, so we've gone through and we've highlighted every single common factor, and now we say which one is the highest of all these numbers. So between 1, 2, 3, 4, 6, and 12, what is the highest number out of that? Well, the highest number would be 12. So we circle 12. Done. Okay, now then we could write off to the side, highest common factor of 36 and 24 is equal to 12. Okay, now I'd really like to see, if you're going to do this method, to make sure you list out all the factors of each, okay, because part of that's sort of part of what we're getting you to do. Okay, now there's a little bit more of a more advanced way of finding this, and we have a look at it. It's called something called Euclid's algorithm. Okay, so we can use Euclid's algorithm to efficiently calculate the highest common factor for two numbers. Now this HCF thing is also known as, in other circles, the greatest common divisor. Okay, so a factor is also a divisor. Okay, right. So let's take, for instance, our numbers we had before. So let's do highest common factor of 36 and 24. Okay, now when we're going about Euclid's algorithm, so you get the first one, 36 equals, now think to yourself, how many times does 24 go into 36? Well, it only goes once, times 36, remainder, sorry, not once times 36, 1 times 24, remainder, plus an extra 12. Okay, then you say, okay, I'm going to take these two numbers here, the 24 and the 12, and they become my next numbers I'm investigating the next line. So 24 is some amount of times 12 plus something. Okay, so you can kind of see the pattern that might start happening with this algorithm. So 24 is 2 lots of 12 plus 0, because there's no remainder. Right, once you've got no remainder here, the leftover number here is our highest common factor. Okay, so you might think, oh, that's a bit weird. Well, I want to show you another example. Let's see it working for another set of numbers that's maybe not as obvious as our last pair. Okay, so let's have a look at it. So let's go highest common factor of, let's go 1071 and 462. Okay, now I don't know my 1071 times tables, or even the times tables that have 1071 as a multiple. So let's have a look at how we might use Euclid's algorithm for this. Okay, so 1071 is equal to some amount of times 462 plus some remainder. Okay, right, so 3 times 462 is not going to fit inside here, so it's going to have to be 2. Alright, so 2 times 462 is 924, and that's going to leave us, so 924 minus, 1071 minus 924, 1089 is 1. Okay, 147. Okay, so these two here are our new numbers for the next set. So 462 is equal to some amount of numbers times 147. Okay, plus some remainder. So let's think about this. So 2 will be 280, 294. So maybe we'll fit 3 in this. So let's think. 3 times 147 is 341. Yes, 341. Let's just check that. 147 times 3. 3 sevens are 21. 3 fours 12. 14. 441. So 3 times 147. So 462 minus 441 is 21 left over. And 147 is equal to some amount of number times 21. And if I think 14 and a 2, 7, 7 one's a 7, so 7 times 21 plus 0. We finished with 0, so that means that if I've got a 0 here, it means that my highest common factor between the two is this one, 21. And so I could go equals 21. Okay, now so, as you can see, sometimes it takes a little bit of brain power to do. If you've got a calculator, it's going to be a lot quicker to figure out these sort of things off to the side. But it's a lot faster way of going about this process rather than listing out all the factors of those two giant numbers. Okay, now if you didn't quite understand that, didn't quite get it, don't really feel like that's going to be your deal, that's okay, don't worry about it. And I want to invite you to go about using the table version for your highest common factors, but this way here will always work and you'll never get it wrong as long as you apply that algorithm correctly. Okay, so we might go through looking at how that algorithm works in class, and otherwise have a go at some of the exercises, and I will catch you at school. Okay, thanks, bye.